So we're going to do some unit conversions now. Number 61. Soccer is played with a round ball, or maybe it's spherical, I'm not sure, having a circumference between 27 and 28 inches and a weight between 14 and 16 ounces. What are these specifications in units of centimeters and grams? Do you understand what they're trying to ask?
I think they want us to express inches in centimeters and the ounces in grams.
Very good. Excellent. So let's do 28 inches and try to find out how many centimeters that is, okay? So here's how we do this, right? We identify the units that we're after. We said we're going to go inches to what?
Centimeters.
Very good. So we have an equal sign, and we write the units we're after, which is centimeters. And then we draw a straight line like this, and we identify the units that we're provided, 28 inches, the units and the number, like that, and we find ways to convert this unit to that new unit. Now, what do you know about inches?
Didn't we say in class that was 2.54 centimeters per inch?
Oh, good. That's good. Now, if you don't know that, you could always just go look it up on Google. In fact, you can look this up on Google easily, how many inches are in centimeters. That's not the important part of this. The important part of this is the setup like this. The fact that you write the units that you're after, and you start with the units that you've been provided with, the value that you've been provided. What that does is it allows you to see that my units have to be divided by those units here to cancel out, and I need to end up with these units over here. And so I need to identify how many centimeters per inch. That's 2.54 centimeters per inch. And that's easy to ask Google, how many centimeters are there in an inch? And then I can see that this is my value here. This is my conversion factor. 28 times the 2.54 will give me my answer. Now, most of you are at a point where you would say, duh, I already knew that. I'm just going to multiply it by that and just move on. But that's not a good idea, because you need to learn how to practice this dimensional analysis setup. Okay, so our answer, 71.12. We only have two significant figures, though, so our answer is going to be 71 centimeters. 14. Okay, so the second one here, we want to be able to convert what to what?
Ounces to grams.
Very good, ounces to grams. So what do we put over here?
We want it to be in grams.
Good, those are the units we're after, and we start with ounces. How many ounces do we start with?
16, maybe 14?
We'll just use 16, that's good. 16 ounces. Now, do you know how many ounces there are in a gram?
I don't.
Okay, so then we would just bring over here. How many ounces in a gram? 0.035.
1 gram is equivalent to 0.0353 ounces. To convert from grams to ounces, divide the unit of mass by approximately 28.35.
For every ounce. Now, I knew to put grams up here because I want to end in grams, and I knew to put ounces down here because I need to divide out my ounces. So, again, 16 times the 0.035274. And my answer is 0.564. But I only have two significant figures, 0.56 grams. Okay. Oh, wait. 1 gram is that many ounces, so I went the wrong way. 1 gram is that many ounces, so I need to 0.0355274 ounces is equivalent to 1 gram. So I'm not going to take 16 times that value, I'm going to take 16 divided by that value. 0.0355274, and that's going to be my resulting value, which is 453.5, or 53.6. But again, we only have 2 significant digits, so it's going to be 450 grams. That's 2 significant digits. This 0 here is placed there, but without a decimal point, it's not significant. In fact, it's better to write 4.5 times 10 to the 2 grams to clarify the number of significant digits. Okay, good. Women's basketball has a circumference between 28.5 and 29 inches and maximum weight 20 ounces. What are these specifications, units of centimeters and grams? All right, so we should be able to do that now by watching the previous one, right? Let's use 28.5 inches. What units are we after?
We're after centimeters.
That's right, we're after centimeters here for inches. We're going to go to centimeters. 28.5 we can start with in terms of inches. All right. So that is a very important setup. You need to make sure you do that. Don't just say, oh, you divide by this, you multiply by that. If you don't do this, then when the problems become so difficult that you don't know what's going on, you won't know where to turn. Okay? Okay. So, there we go. 28.5, and then inches, centimeters, 2.54 centimeters for every 1 inch. So 28.5 times the 2.54, right? That's our 72.39, 3 significant digits, 72.4 centimeters. All right, where are we going now?
Ounces to grams.
Very good. So I have grams, what I'm after. I'm starting with ounces. Let's use the 20 ounces. Okay, and then I need ounces on the bottom and grams here. Do you remember?
I don't remember how many ounces are in a gram.
Okay, here we go. Let's change this to 1 this time. And it says it's 28.3495 grams. So 28.3495, that's how many grams there are for every ounce. So 20 times that will get us the grams that we're after. So 20 times 28.3495. 566.99 grams. We only have 2 significant figures here, so we're looking at 570 grams for a women's basketball. Okay, very good. Notice that in these 2 different problems that we just did, we used 2 different conversion factors. Both of them are true. 1 gram is that many ounces, and 1 ounce is that many grams, right? They're both ways that can convert between ounces and grams. All right. How many milliliters of a soft drink are contained in 12-ounce can? You know the difference, or the relationship between ounces and milliliters? That's volume, right?
No, I don't know.
So milliliters is what we're after, right? So I write milliliters here, and I'm starting with a 12-ounce can. Now we call these fluid ounces, right? Talking about fluid ounces now. So I want to know how many fluid ounces, how many milliliters are there in a fluid ounce? How many milliliters in a fluid ounce? So
1 fluid ounce is equal to 29.574 milliliters.
all right. So what goes down here? The 29.573 milliliters or the 1 fluid ounce?
Where?
Down here.
That has to be the ounces, right?
It has to be the ounces because we need our ounces to cross out there, right? And so then that means that this has to be the milliliters, 29.5735 milliliters. So we multiply them, 12 times the value. So how many significant digits?
Just 2, 350.
Good, 350 milliliters. A barrel of oil is exactly 42 gallons. How many liters of oil are in that barrel?
Gallons to liters?
Yep, that's what we need. That's right.
How many gallons per liter? What is that?
Let me try. How many gallons per liter?
That's what I said.
Well,
To convert from liters to liquid gallons, divide units of volume by approximately 3.79.
okay, so 1 liter, that many gallons, right? Another conversion factor that we could use here is just how many gallons, or yeah, liquid gallons to liters, right? How do we set up our conversion factor, our dimensional analysis?
The units you're after.
What are we after?
Liters.
Very good. We want liters. What do we start with?
42 gallons.
42 gallons. Which values do we put where?
Gallons on the bottom.
That's right. So if I use these ones right here, 1 gallon on the bottom, 3.78541. Now, because I'm using only 2 significant figures here, I don't need 1, 2, 3, 4, 5, 6 significant figures. I could get away with just 3, because this is going to be limiting my number of significant figures. So I could go 3.79, for example, 42 times 3.79, and I can get 159.18, and I'm going to round that to 2 significant figures, which is 160 gallons, or liters, sorry. We ended up with liters, 160 liters. All right, if I were to have gone 42 times 3.785, right, I still get, well, there I get 159 liters. So if I go 42 times 3.7854, then I get 159 again. All right. So if you maintain 2 significant digits more, so this is 2, if I maintain 4 significant digits there, then that'll ensure that I get the right number, 2 significant digits. All right. The diameter of a red blood cell is about that many inches. What's the diameter in centimeters?
Just divide by 2.54?
Okay, maybe, but you don't want to rely on that sort of thing. You want to use your dimensional analysis.
Okay, okay.
So what are the units we're after?
Centimeters.
All right, centimeters. Whoops.
And then 3 times 10 to the minus 4 inches.
3 times 10 to the minus 4 inches.
And then inches on the bottom.
Inches on the bottom.
Centimeters on the top.
Centimeters on the top. 1 inch is 2.54 centimeters.
So you multiply by it.
Yeah, we didn't divide by it. We multiplied by it, right? So I go, now here's how I write 3 times 10 to the minus 4 into my calculator. I'm going to turn it sideways so you can see the buttons as I do it. All right, this is important that you write this into your calculator the right way. If you don't have this kind of calculator, then you're going to make sure you look on YouTube and find out how to write scientific notation in your calculator the right way. Okay? All right, we write 3 times 10 to the minus 4. All right, and now what do I have to do? I have to multiply that by 2.54. When I multiply that by 2.54, then it will give me the correct number, or not correct number, but it'll follow the scientific notation correctly. Okay? It's not scientific notation. It'll follow the order of operations correctly. So sometimes calculators get confused if you don't write the scientific notation the right way. All right, so 7.62 times 10 to the minus 4. How many significant digits are we going to keep?
Just 1.
That's right. So we got 8 times 10 to the minus 4 centimeters as the diameter of a red blood cell. Okay. Number 66, the distance between the centers of 2 oxygen atoms is that many centimeters, and we want to know that length in inches.
Okay, so Equal sign inches.
That's right. It's always important that you start off with an equal sign and the units you're after.
And then we're in centimeters.
So they gave us our value in centimeters.
1.21.
1.21 times 10 to the minus 8.
Yeah.
And so centimeters have to go down here and inches have to go down here. 2.54. Let's get one more significant digits for our centimeters to inches. So let's go to length, centimeters, and inches. Make the inch 1, 2.54. That's it. It's an exact number. All right, good to know. So 2.54, 1.21 times 10 to the minus 8 divided by 2.54. All right. So 1.21 times 10 to the minus 8 divided by 2.54. Now it's very important that you remember how to write the scientific notation into your calculator that way. If you don't know how, go ahead and look on YouTube and try to figure out how to do that. But the result here is 4.76 times 10 to the minus 9. I have those three significant digits only, so 4.76 times 10 to the minus 9 inches. That's the distance between two oxygen atoms, 10 to the minus 9. So 4.76 nanoinches. 197 pound weightlifter, light enough to compete in the 90 kilogram class. That's a good question. Is 90 kilograms, how does 90 kilograms compare to how many pounds are in 90 kilograms? Or how many kilograms are in 197 pounds? Which one do you want to do?
Let's go pounds to kilograms.
Pounds to kilograms. So we want kilograms here. We start with 197 pounds. I need pounds down here and I need kilograms up there. So I'm looking for how many pounds there are in a kilogram.
1 kilogram is 2.205 pounds.
1 kilogram is 2.2046 pounds. All right, I have three significant figures here. I'm going to get 1, 2, 3, 4, 5 significant figures going in there then. So 197 divided by 2.2046. So we got 89 kilograms. 89.4 kilograms, right? So I round with this 5, round that 3 up. 89.4 kilograms. Is enough to be limited to those weighing 90 kilograms or less? Yeah, they weigh less than 90 kilograms. So if you weigh less than that, then you can wrestle in it or compete in it or whatever it is. Okay, good. A very good 197-pound weightlifter lifted 192 kilograms in a move called a clean jerk. What was the mass of the weight lifted in pounds? So how do we set this up, Fred?
An equal sign.
Very good. Equal sign.
We want pounds.
Very good. Says what was the mass in pounds. What do we start with?
Kilograms. 192.
Yes. 192 is how much they lifted, right? And we want to know how many pounds it is. I know that 1 kilogram is equal to 2.2046 pounds. Is that the way I want to use the conversion factor? Put that right in there.
Not quite. You want to flip it.
Right. I need my kilograms down on the bottom, and I need my 2.2046 pounds up top. So 197 times the 2.2046, and that should be our answer. Good. Many medical laboratory tests run using 5, what is that weird looking thing?
Microliters.
Good, microliter blood serum. What volume is that in milliliters?
5 microliters?
Yeah.
Isn't it just 5 million milliliters?
Is it?
Oh, no, it's the other way, isn't it?
It is the other way, right? And, just to minimize confusion or remove confusion, again, we don't have to sit and guess, try to rely on our intuition. we say we want to know milliliters. We have microliters. It's 5.0 microliters. And now I can go microliters to milliliters. Now, I might not be able to do that one in my head. Maybe I should go microliters to liters, or do I know microliters to milliliters?
Well, I think I know that one.
Well, let's pretend like we don't. Maybe we go microliters to liters. All right, we know that, right? 1 times 10 to the minus, or not minus, 10 to the 9, or 6, sorry, microliters for every liter. And now that I'm in liter, I can go from liters to milliliters. There's 1,000 milliliters for every liter. So this value divided by 1 times 10 to the 6th times 1,000, that'll tell you how many milliliters there are.
Couldn't you have just divided by 1,000?
You can do the same thing if you go 5.0 microliters and you want to go to milliliters. And if I knew that there's 1,000 microliters for every 1 milliliter, right? That'll do the same thing. So 5 divided by 1,000, 1, 2, 3, 0.0050. Maintain the 2 significant digits here. Milliliters for every 5 microliters. 5 divided by 1 times 10 to the 6th times 1,000 will also give us that same value. Okay, good. If an aspirin tablet contains that much aspirin, how many grams of aspirin does it contain?
325 milligrams?
Yep. If I have 325 milligrams of aspirin and I want to know grams of aspirin, how do I do that conversion?
Milligrams on the bottom.
Very good. The units tell us what I need to do. Grams on top, right?
Yep.
Okay. So how many milligrams per grams?
Let's see. Is that 1,000?
That's right. 1,000 on top here.
1,000 on top? I mean, no, 1,000 on the bottom.
That's right. There's 1,000 milligrams for every 1 gram. So that divided by 1,000, 1, 2, 3, 0.325 grams, that's equivalent to 325 milligrams. Okay, good. All right, so 71. We're going to use scientific notation to express these quantities, but in SI units. All right, so in SI units, this isn't terribly important to remember because, again, different labs use different units. But the SI unit for mass is not grams, it's kilograms. So now we want to express 1.31 grams in kilograms in scientific notation. All right? So if I want to know how many kilograms are in 0.13 grams, right? Is that right?
Looks good.
What goes down here?
Grams. And then kilograms.
Very good. And now I need my units for my conversion factor. And there's 1 kilogram has 1,000 grams. So it's 0.13 grams divided by 1,000. So it's 0.12313, right? I'm adding 1, 2, 3 more zeros onto there. That's my answer. And now I have to write that in scientific notation.
That's 1.3 times 10 to the minus 4?
1.3 times 10 to the minus 1, 2, 3, 4 kilograms. Very good. Next one.
What's big G? Giga?
That's right, gigagrams. So I have 232 gigagrams, and I want to write that in kilograms. All right. Kilograms. I'm starting with gigagrams. Going from gigagrams to kilograms isn't something that's really firm in my head, right? So instead I just go from gigagrams to grams, and then I can go grams to kilograms. This one's easy and this one's easy. Just simplify it. 1 kilogram, 1,000 grams. Giga is 1 times 10 to the 9th. So there's 1 times 10 to the 9th grams for every gigagram. I could have said 1 times 10 to the minus 9 gigagrams is 1 gram. All right. So the number here is 232. Times 1 times 10 to the 9th divided by 1,000. All right. So there's a couple ways of thinking of this. There's 9 zeros here, 3. So it's just putting 6 more zeros onto there. If I multiply this by 1 times 10 to the 9th, I'll do it in my calculator so people can see. 232 times, again, we want to write scientific notation the correct way. 1 times 10 to the 9th, 1 times 10 to the 9th, divided by 1,000. All right, so we got 232 with those 6 extra zeros. That's how many kilograms. And now scientific notation.
2.32 times 10 to the 8.
That's right, times 10 to the 8th kilograms is equivalent to 232 gigagrams. Okay, 5.23 picometers. 5.23 picometers, and I want that in regular old meters. So do you know picometers to meters?
Isn't that 10 to the, let's see, micro is minus 6, nano minus 10 to the minus 12?
Very good. So 10 to the minus 12 meters for every picometer, or 1 times 10 to the 12th picometers for every meter. So I have to divide this 5.23 times 1 times 10 to the 12th. So 5.23 divided by 1 times 10 to the 12th. So 5.23 times 10 to the minus 12 is the number of meters in 5.23 picometers. Milligrams to grams. Now when we're dealing with grams and milligrams, we should probably be able to do this by memory, because that's something that we have to do frequently in the lab. So if I have 86.3 milligrams, I want to go to grams. There's 1,000 milligrams for every gram. So I can just go 1, 2, 3, 0.0863 grams. That's how many, that's equivalent to 86.3 milligrams. 37.6 centimeters. I want to go from centimeters to meters. 100 centimeters for every meter. So we're going to divide that by 100. 0.376 meters. Oh, we forgot to write these in scientific notation. 8.63 times 10 to the what, Fred?
Minus 2?
Good. And 3.76 times 10 to the?
Minus 1.
Very good. All right, so we're at 54 micrometers. 54 micrometers, we want to get that in meters. All right. Want to get it in meters, micrometers, meters, 1 times 10 to the 6 micrometer for every meter. So that, moving the decimal place 6 times, 1, 2, 3, 4, 5, 6. So 0.40 is 1, 2, 3, 4, 5, 4, right? Started here, 1, 2, 3, 4, 5, 6. Now to get it in scientific notation, 1, 2, 3, 4, 5, 5.4 times 10 to the minus 5 meters. That's equivalent to 54 micrometers.
TS, what's that?
That's a terasecond. Terasecond. Lots and lots of seconds, huh? In a terasecond. You remember what tera is?
10 to the 12th?
That's right. 10 to the 12th seconds for every terasecond. So, we want to know seconds. That's our SI unit. We're in teraseconds. We have 1 terasecond. We have 1 times 10 to the, 1 terasecond is 1 times 10 to the 12th seconds. Teraseconds cancel out. So I have 1 times 10 to the 12th seconds for every terasecond. 27 picoseconds. 27 picoseconds. 27 picoseconds. Any ideas how many seconds?
Just divide by 10 to the 12th.
That's right. Good job. So I want this in seconds. And this is in picoseconds. Every picosecond, seconds, oops, SEC here. Right, 1 second is 1 times 10 to the 12th picosecond. So 27 divided by 1 times 10 to the 12. 27 times 2.7 times 10 to the minus 11. Already given to us in scientific notation. 0.15 milli K. That's Kelvin. I don't know if you recognize that, but 0.15 milli K. And I would like regular old K, Kelvin. All right, so I have milli K down here and K up here. I knew that because my units, right? So 1 Kelvin, it has 1,000 millikelvins in it. So that divided by 1,000, I'm going to move the decimal place over 3 times. 1, 2, 3, 1, 5, or 1.5 times 10 to the minus 4. 1, 2, 3, 4. Kelvin is equal to 0.15 millikelvin. Okay, good. Number 72. Complete the following conversions between SI units. 612 grams going to milligrams. All right. I'm getting pretty good at this now. 612 grams. If I want to go to milligrams, I just need to multiply this by 1,000 to get to a milligram, right? I need milligrams over here. I'm starting with 612 grams. It's 1,000 milligrams for every 1 gram. Whoops, that's grams. I need the 1 gram down here, 1,000 milligrams there. Very good. So this times 1,000, 612,000. That's how many milligrams there are in that many grams. And I maintain the same number of significant digits. Or in other words, 6.12 times 10 to the 5th milligrams. All right. The second one there, 8.160 meters to centimeters.
I can do this one.
Thank you.
8.160 meters, and you want centimeters.
I want centimeters.
8.160.
Okay, what now?
That's meters. Meters on the bottom, centimeters on top. 100 centimeters for every meter. So it's just multiplied by 1,000.
Very good. 816.0 centimeters for every 8.160 meters. 4 significant digits. Oh no, there's only 3 significant digits there. So I'm only going to have 816. Keep my 3 significant digits. Oh no, sorry. There is 4 significant digits there, so I need to keep that 4th significant digit as well. All right. Micrograms to grams.
Just divide by 6 zeros.
Very good. Divide by 6 zeros. So it goes 1, 2, 3, 4, and then 2 zeros in front. So 0.003779 grams.
Yep.
All right. Milliliters to liters.
Divide by 1,000.
That's right. 781 milliliters. There's fewer liters by 1,000. 1, 2, 3, 0.781 liters.
We divide by, or times by 1,000.
That's right. Kilograms is larger than grams. So I have 1, 2, 3, 4,180 grams. This answer there has 3 significant figures in it. That 0 is just a placeholder. I don't have a decimal point. I can clarify by going 4.18 times 10 to the 3rd grams. All right, 27.8 meters. How many kilometers?
It's less, right? So 0.0278.
Very good. 0.13 milliliters. How many liters?
0.13 milliliters to liters. It's less again, so divided by 1,000.
Very good. So 0.00013 milliliters in every liter. 1,738 kilometers.
1.738, no, times 1,000, right?
That's right. So 1,738,000 meters for every 1.738 kilometers. Gigagrams, 1.9.
That's 10 to the 12th, right?
Is it 10 to the 12th or 10 to the 9th?
Oh, 10 to the 9th.
So 1.9, move the decimal place over 10 times or 9 times to get it to grams. Okay, good. Gasoline is sold by the liter in many countries. How many liters are required to fill 12-gallon gas tank?
You need to know liters for 12 gallons.
That's right, 12 gallons. I want to know how many liters. You know how many liters there are per gallon?
I can't remember.
So we just put it into Google. How many liters per gallon?
To convert from liquid gallons to liters, multiply units of volume by approximately 3.79.
3.7854, right? That's how many liters per gallon. Okay, I want my liters to be on top or bottom.
On top.
I want my liters to be on top because they need to end up the units there, gallons on the bottom so that they can cancel out when they divide out. So 1 gallon, 3.7854 liters. So 3.7854 times 12 will be your answer. Milk is sold by liter in many countries. What volume exactly is half a gallon of milk in liters? Okay. What volume of liters is 0.5 gallons? So same thing, gallons on the bottom, liters on top, 3.7854 times 1. All right, so 0.5 times the 3.7854 will give you the liters. A long ton is exactly 2,240 pounds. What's this mass in kilograms? So I want kilograms. I have 2,240 pounds. Pounds need to be on the bottom so they cancel out and leave behind kilograms. All right. I identify how many pounds there are in a kilogram. Whoops. Mass, pounds, kilogram. 1 pound is that many kilograms. If I put a 1 here, 2.204 pounds. So where does my 2.204 go? On top or the bottom?
On the bottom.
That's right, it goes with the pounds. 2.205 pounds for every kilogram. I got 3 significant digits here, so I'm going to use a little bit more, 2.20462. So my answer is 1016. If I have 2,240 pounds, 1 kilogram is 2.204 pounds. So I have 1,016 kilograms. All right. Make the conversion indicate each of the following. In each of the following. Men's world jump record, 29.4 feet. 29 feet, 4.4 inches to meters. That's a little bit tricky because the 29 feet and 4.1 inches are not in decimals, right? It's kind of confusing. So let's just get it all to inches. So 29 times 12, that's 348 plus the 4.25. So 352.25. That is going to only have 2 significant digits, so 350 inches. And now I want to go from inches to meters. Okay, inches to centimeters, I know that. 1 centimeter is 4.25 centimeters is 1 inch. And then centimeters to meters, I know that 1 meter is 100 centimeters. So 350 times 4.25 divided by 100. So 14.875, two significant digits, 15 meters. The depth of the ocean, 6.5 miles. We want it in kilometers. Miles. I don't know if I remember exactly. It's like 2,860 feet. How many feet in a mile?
1 mile is equal to 5,280 feet. To convert from miles to feet, multiply the unit of length by
So
5,280
feet per mile, and then feet can go to inches, and then inches to centimeters, and then centimeters to meters, and then meters to kilometers. That's a lot. But that's a good example of how you can just use the easy ones that you know and you can eventually get there. That's all right. 12 inches, 1 foot, 1 inch. This is centimeters, yeah, 2.54. 1 meter, 100 centimeters. 1 meter, 1,000 meters for every kilometer. So I'm going to do 6.54 times 5,280 times 12 times 2.54 divided by 100 divided by 1,000. 10.53 kilometers, and we only have two significant digits, so it's going to be 11 kilometers. Okay, the area of the state of Oregon is that many miles squared. How many kilometers? Now, this should say how many, oh, there it is, yeah, square kilometers. How many square kilometers? Okay. So, when we're doing squares, it's a little bit different. 9,698 miles squared. 96,981 miles squared. And I want my answer in kilometers squared. I can follow the same pattern. Miles, remember how many feet?
Was it 5,280?
Feet. But that's a mile. A mile squared, you have to square both of those like that. So 1 mile squared is 5,280 feet squared. And then I can go feet to inches. 1 foot squared is 12 inches squared. And then I can go inches squared to centimeters squared.
2.54 squared?
That's right, 2.54 goes squared though, don't you? And then centimeters squared to meters squared, and then meters squared to kilometers squared. So 1 kilometer, 1,000 meters squared, 100 squared centimeters is 1 meter squared. So we have to square everything like that. So it's not just 1 in the 5,280. 1 mile squared is 5,280 feet squared. So I have to square the 5,280. So I have the 96981 times 5,280 squared times 12 squared times 2.54 squared divided by 100 squared divided by 1,000 squared. All right, so it should be how many significant figures? 5. 1, 2, 3, 4, 5. 25118 kilometers squared. Okay, 1 gill. I've never heard of a gill. 4 ounces to milliliters. All right. So if I go from gills to milliliters, 1 gill to milliliters. I'm told that 1 gill is how many ounces?
4 ounces.
So a gill to ounces, 4 ounces for a gill. And then how many ounces for a milliliter?
Oh, I can't remember.
Let's look that up. How many ounces per milliliter?
1 milliliter is equivalent to 0.0338 fluid ounces.
So I'll put the 1 on that side, just give us a whole, or larger than 0 numbers. Larger than 1. 1 milliliter or ounce, 29.5735. Milliliters for every ounce. Okay, we should be there. We just have to take that 1 times 4 times the 29.375.
117.
That's right. How many significant digits?
Just 1, I guess.
That's right. Just got 1 gill. So 100 milliliters. That's not very accurate, but we only get 1 significant figure there, so we just have to take 1 significant figure for our answer. Okay. Estimate volume of the ocean, 330 million miles cubed to cubic kilometers. Okay. This is a good one because what this does for us again is it allows us to use units that are either, cubed in this case, right? So we have miles and we want to go to kilometers again. So we know this is one we've done a couple times already, so it's a little bit long. 330, 1, 2, 3, 1, 2, 3 miles. Cubed though this time. Miles to feet, what was it?
5,280.
Good. 5,280 feet for every mile. It's got a cube though, right? Because it's every cubic mile. Feet to inches, cubic feet to cubic inches, inches to centimeters, cubic, centimeters to meters, cubic, meters to kilometers. And that's what we're after, cubed. So 1,000 meters cubed, 100 cubed, 2.54 cubed, 12 cubed, all right, we're there. Just got to do the math. 330, 0, 0, 0, 0, 0, 0, 0 times 528 0 to the third times, whoops, that times can't go there. I'll say equals there. Whoops, go to, gotta get rid of that there. There we go. So we just did that first step because of the cube getting in the way. So now we multiply that by 12 to the third. Now we multiply that by 2.54 to the third. Now we divide that by 100 to the third, 100 cubed. And we divide that by 1,000 cubed. All right, so we got 1.37, only 2 significant digits, so 1.4 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Times 10 to the 9th kilometers. Okay, good job. The mass of a 3,525 pound car in kilograms. Kilograms, pounds, how many pounds, how many kilograms? Was it 2.2, something like that?
Yeah, something like that.
So probably 2.25. We go to mass, pound, kilogram, 2.205. That's how many pounds there are in each kilogram. So 2.205 pounds per kilogram. If we start off with 3525, 4 significant digits. So I'm going to take 7 significant figures on my pounds. So 3525 divided by 2.20462. That's how many pounds there are per kilogram. I got 4 significant digits again, 1599 kilograms. All right. Are you tired, Fred?
Yes, I'm tired.
I thought so. I haven't heard you for a while.
Well, you're doing fine.
Okay. Do you have any questions?
No, I get the idea. You just keep multiplying and dividing, right?
Yep. You find the conversion factor. You work it out, right? You identify the units you're after. So we want to go grams for this last one. What are the units we start with?
2.3 ounces.
2.3 ounces. How many ounces in a gram? Do you know?
Can you look it up?
Yeah, I can. There's, for every gram, there's 28.35 or 3495. Sorry, for every ounce, there's 28.3495 grams. So, what goes on top? What goes on bottom?
Grams goes on top.
28.3495 grams for every 1 ounce. I know I need my ounces to divide out, and I need to be left with grams. 2.3 times 28.3495. Oops. $65.2 or just 65 grams. Okay, lots of work. Good job. P7, we want to go from where? Where's our conversion?
Meters to feet.
So where does my feet go?
After the equal sign.
Start with meters. How many?
120.
120 meters. And I want to go to feet. So meters goes where?
On the bottom.
Do you know how many meters there are in a feet?
I don't know. I know meters to centimeters.
Very good. Meters to centimeters is good because then we can go centimeters to inches and then inches to feet, right? 12 inches for foot, 2.54 centimeters per inch, 100 centimeters per meter. So 120 times 100 divided by 2.5 and divided by 12. All right. Okay, and the answer is 393 feet. Okay, good. Significant figures, just 2, so 390 feet. All right. The height of this mountain, 19,565 feet. And I want to go to what?
Kilometers.
Kilometers. How do I go from feet to kilometers?
Inches to centimeters.
Very good. That's the crossover, right? So feet goes to inches, and then inches can go to centimeters, and then centimeters can go to meters, and then meters can go to kilometers. So 1,000 milliliters per kilometer, 100 centimeters per meter, 2.54 centimeters per inch, 12 inches per foot. So 19,565 times what?
12.
Then what?
2.54
Then what?
divided by 100. And then 1,000.
Divide by 1,000 again. All right. So, or once. So I get 5.96, and I have 5 significant digits, so 5.963, 4. And kilometers, is that what I was after? Yeah. Okay, good. That's the highest mountain in Africa. Area, 8.5 by 11 inches in centimeters squared. Well, that's a fun one, right? I like the squared ones. 8.54 by 11. Whoops, this is here. The 11 is here. Not 8.54, just 8.5, 11 inches there. And we would like to know it in centimeters. All right. Why don't we find what the square surface area of the plate is, the paper is to start off with. 8.5 times 11. That's, what did I do? 93.5 inches squared. All right. With 2 significant digits, 94. And I want to go to centimeters squared. Inches to centimeters, 2.54 centimeters for every inch. But I need to square it if I want to go centimeters squared to inches squared. So 93.5 times 254, or 2.54 squared. So 603.2, 2 significant figures, 600 centimeters squared. The displacement of the volume of an automobile engine, 161 inches cubed to liters. Inches cubed to liters. All right, inches cubed to liters. Do you know inches cubed to liters?
No, we got to use the centimeters to inches again.
Very good, centimeters, because centimeters cubed is a milliliter, right? Centimeters cubed is a milliliter. So inches cubed to centimeters cubed, and then centimeters cubed to milliliters. Centimeters cubed is a milliliter. All right, so how many inches cubed?
161.
161 inches cubed. So I go 1 inch, 2.54 centimeters, but I have to cube it, right?
Yeah.
Centimeters, 1 centimeter cubed is 1 milliliter. I don't need to cube anything there. That's the definition of a milliliter. It's a centimeter cubed of whatever material we're talking about. Then I can go from milliliters to liters. 1,000 milliliters for every 1 liter. So 161 times 2.54 cubed, and then divided by 1,000. And that should give me 3 significant digits, 2.63 liters. All right. The estimated mass of the atmosphere, 5.6 times 10 to the 15 tons. Whoa, that's a lot of atmosphere. 5.6 times 10 to the 15 tons. 2 kilograms. Do you know how many tons there are? What is a ton?
That's 2,000 pounds.
Can we get there with pounds? I guess we could go from tons to pounds, and then pounds to kilograms. Yeah, that's it. How many pounds are there per ton?
2,000 pounds.
2,000 pounds for every ton. And then, was it 2.205 kilograms per pound? Let's look it up here. .205 pounds per kilogram. 2.205 pounds for every kilogram. Okay, so we got 5.6 times 10 to the 15 tons times 2,000 divided by 2.205. And that 2.205 should be plenty of significant figures to make sure we have our answer in two significant figures. 5.1 times 10 to the 18 kilograms. That's how many pounds or kilograms there are in 5.6 times 10 to the 15 tons. All right, a bushel of rye, 32 pounds. How many kilograms? All right, 32 pounds. We're going to kilograms. We know that there are 2.205 pounds. I know pounds have to go on the bottom because they need to cancel out for every 1 kilogram. So 321 or 32.0, 3 significant digits, divided by 2.205. So we got 14.5, 3 significant digits, kilograms. 5-grain aspirin tablet, 5 grains. A grain is that many ounces. How many ounces are there in a pound? 1 ounce, 0.0625 pounds. So if we start with what?
The 5 grains?
Very good. Grain, not something we use very frequently, is it?
Nope. We want to go to milligrams.
Milligrams. I can go from grains to what?
Ounces, it tells you.
All right, so 0.00229 ounces for every grain, and then ounces to pounds. 1 ounce, 0.0625 pounds. I popped that up on Google over there, and now I go from pounds to kilograms. 2.205 pounds for every kilogram. And then I can go from kilograms to grams, and then I can go from grams to milligrams. 1,000 grams for every kilogram, 1,000 milligrams for every gram. So 5 times 0.00229 times 0.0625 times 1,000, or divided by 2.205 times 1,000 times 1,000. All right, so it should be one significant figure, 300 milligrams. 300 milligram tablet. Great. 78. So if I've run 50 trillion angstroms, how long of a run is that in kilometers?
I have no idea.
Yep, me neither. So what we do here, though, is we start with our units and end with the units, right? So I want to end in what?
Kilometers?
Let's do miles. Is that okay?
Okay, miles.
So 50 trillion angstroms. A billion is 10 to the 9th. A trillion is 10 to the 12th. So 50 times 10 to the 12th angstroms. An angstrom. Let's look it up. Look it up on YouTube or on Google. Angstrom. There are 10 angstroms in 1 nanometer. Yeah, level check here. How many angstroms in a nanometer?
1 nanometer is equal to 10 angstroms.
Yeah. So 10 angstroms, 1 nanometer. If I want to go from nanometers to meters, what do I want to do? I want to get to, I want to get from meters, kilometers to miles. I can do kilometers to miles. So nanometers to meters. I'm going to go from meters to kilometers, and then kilometers to miles. So there's 1 times 10 to the 9th nanometers for every meter, 1,000 meters for every kilometer. How many kilometers per mile? How many kilometers per mile?
To convert from miles to kilometers, multiply the unit of length by approximately 1.61.
1.60934 kilometers for every mile. All right, so calculator time, 5 times 10 to the 12th. Oh no, 50 trillion angstroms. So 50 times 10 to the 12th. 50 times 10 to the 12th angstroms divided by 10 divided by 1 times 10 to the 9th divided by 1,000 divided by 1.60934. So about 3.1 mile. That is how long 50 trillion angstroms is. Okay. So number 80, the gas tank of a certain luxury automobile holds that many gallons according to man. The density of gasoline is that much. What's the mass in kilograms that can be found in the tank? Okay, so now we move on to using density as in conversions, densities in conversions, which is absolutely pretty much the same thing we've been doing, but we just haven't talked about densities yet, right? All right, but I want to know the mass in kilograms. So I want kilograms. And I'm starting with what?
22.3 gallons.
22.3 gallons. And then where can I go?
Well, they tell you 0.8206 grams per milliliter.
I'll write that down, 0.80 or 0.8206 grams per milliliter. How does that help me?
Well, you can go from gallons to liters, right?
Yeah, we can go from gallons to liters. And your gallons need to be on bottom, right?
But then liters to milliliters, maybe.
Liters to milliliters, all right.
And then milliliters to grams.
Milliliters to grams. How do you go from milliliters to grams?
Well, that's what the density says, 0.8206.
0.8206 grams for every 1 milliliter, right?
Yeah.
Okay, and then there's 1,000 milliliters per liter. How many liters are in a gallon?
I can't remember.
How many liters per gallon?
To convert from liquid gallons to liters, multiply units of volume by approximately 3.79.
Liters per gallon. So now we're in units of grams, and we just need to go from grams to kilograms because there's 1,000 grams for every kilogram. So can you see how we use the density in there? It converts grams to milliliters because it tells us how many grams there are for every milliliter. Okay, so we have our 22.3 times 3.785 liters for every gallon times 1,000 milliliters times 0.8206 divided by 1,000. So we got 69.3, three significant figures, kilograms. Okay, so that was number 80, 81. Where's the mouse? There we go. An instructor is preparing for an experiment. He requires 225 grams of phosphoric acid. The only container readily available is a 150 milliliter Erlenmeyer flask. Is it large enough to contain the acid, which density is 183.8 1.83 grams per milliliter. So I want to know, do I have 225 grams if I have 150 milliliters? So how many grams do I have if I have 150 milliliters of the acid? Well, I have a density thing that says 1.83 grams per milliliter. Milliliters has to go on the bottom, and grams is going to go on top. It's 1.83 grams for every milliliter. So 150 times the 1.83 is 274.5. And I want 225 grams. So yes, I should have, wait, hold on a second. Oh, he needs 225. He needs 225. I have 150 milliliters, so yes. I have 274.5 grams. Is that right, Fred?
Yeah, that's right. You needed only 225 and you got 274, so you got plenty.
All right, good. 82. A student needs 125 grams of a compound. The bottle contains a quarter pound. Does the student have enough of the compound? Grams to pounds. So if I want to know how many grams I have 0.25 pounds per gram. We just did this one, didn't we? There we go. How many pounds per gram?
4 grams is 0.00882 pounds.
So if I have 1 pound, that's 453.6 grams. All right, so 453 times 0.25, whoops. $113 grams, and I need 125. 110 grams with the right number of significant figures, right? And I don't even know how many significant figures are in this 1/4. Okay, probably just one. So. All right, a chemistry student, 159 centimeters tall, weighs that much. What is her height in inches and weight in pounds? I think you guys are good enough to go from centimeters to inches and kilograms to pounds. Let's go on to number 84 here. In a Grand Prix race, the winner completed the race with an average speed of 229.8 kilometers per hour, and we want to know that in miles per hour, meters per second, and feet per second. Okay, so this is a nice example of what we can do when we have multiple units, 229.8. What are my units?
Kilometers per hour.
That's right, kilometers. And we need to make sure that when we write that, we recognize that we're going to, let's say, miles per hour first. Kilometers per hour, or HR right here. All right. So I have hours on the bottom. I just need to get kilometers to miles, right? How many miles in a kilometer?
1 kilometer is 0.621 miles.
So that times 0.621 will give me the miles per hour. If I wanted to go for meters per second, right? Well, let's do meters per second. And I'm starting with 229.8 kilometers per hour. I can go 1 kilometer, 0.621. Oh, wait, I don't want to go to miles, I want to go to meters. So 1,000 meters for every kilometer. And then I have to go from hours to seconds. So there's 60 minutes, and there's 60, or 1 minute contains 60 seconds. So see how I had hours down here. I need to get hours into minutes. 1 hour is 60 minutes. And then I need to get these minutes into seconds so I can have seconds in the bottom. So if hours is on the bottom, I multiply by hours on top, get minutes on the bottom. Get rid of the minutes, 1 minute. This says 1 minute here. Divided by 60 seconds. So my meters is left over and my seconds is left over. Okay, good. Feet per second, I'll bet you could do that as well. Okay. In a recent Grand Prix race, we just did that one. Where's the mouse? Okay, so now we're going to solve number 85 here. It's a lumber problem. 2x4 must be converted into metric units. The thickness, width, and length dimensions are 1.5, 3.5, and 8 feet inches in the US. What are these dimensions in centimeters, centimeters, and meters? How fun. 1.5 inches to centimeters. That's easy. 1 inch, 2.54 centimeters. Right? So 1.5 times 2.5. 3.75. 3.5 times 2.54. 8.89. And then the other one goes 8 feet into meters. So if I want to go from 8 feet to meters, I go from feet to inches, and then inches to centimeters, and then centimeters to meters. So 1 foot, 12 inches, 1 inch, 2.54 centimeters, and 2.54 centimeters, 100 centimeters for every meter. So 8 times 12 times 2.54, that's in centimeters, divided by 100, that gives us to meters. So 2.44 meters. So this is centimeters, centimeters, meters. Okay, this number can be used as vertical studs, which are typically placed 16. What is the distance in centimeters? 16 inches apart, distance in centimeters. You can do that. Okay. All right. Number 87. Calculate the density of aluminum if 27.6 cubic centimeters has a mass of 74.6 grams. How do we do this one, Fred?
Density is mass over volume, so just the 74.6 divided by 27.6.
Very good. That's right. Density is mass over volume. Osmium, most dense. There's its grams. There's its volume. Same thing. Mass over volume gives it its density. Calculate these masses. What is the mass of that much volume of mercury if the density is that much?
We want the mass.
We want the mass.
We have the volume.
We have the volume. Well, how much volume?
6.
6 cubic centimeters.
Yeah.
And the density will allow us to go from centimeters cubed. I know I need that on the bottom. Grams on top. It's 13.5939 grams per cubic centimeter, but that times that will tell us how many grams. What's the mass of 25 milliliters of octane if it has that density? I want grams of octane. I have 25.0 milliliters. I go from milliliters to grams using the...
Wait a second, milliliters or cubic centimeters?
That's a good point. Milliliters is the same as cubic centimeters. So I could put in here one extra where I go from milliliters to cubic centimeters, and then from cubic centimeters to grams, because it's 0.702, sorry, grams for every cubic centimeter, and 1 milliliter is 1 cubic centimeter. So that's, it doesn't matter, it's the same thing. 1 centimeter cubed is 1 milliliter. 1 cubic centimeter is that many grams, right? Let me rewrite that. 25 milliliters. 1 milliliter is 1 cubic centimeter. 1 cubic centimeter has a mass of 0.702 grams, and I'm after grams. Okay, calculate these masses. 4 cubic centimeters of sodium, and the density is 0.97 grams for every cubic centimeter. So I want grams again, and I know that I have 4 cubic centimeters, and it's how many grams per cubic centimeter?
0.97.
0.97 grams for every cubic centimeter. There we go. Mass of 125 mils of gasoline given its grams per liter. All right, so the density there is, I want to know the mass of the gasoline. And I start with 125 milliliters. But I have density in what?
Grams per liter. So you got to convert the milliliters to liters first.
So we go from milliliters to liters, and then I can go grams to liters with the density, right? 3.16 grams for every liter. 1 liter, 1,000 milliliters. Okay, good. Calculate these volumes. What's the volume of 25 grams of iodine if the density is that?
Just grams per cubic centimeter, right?
Yep, same thing. So this time I'm after volume, I'm after cubic centimeters. And I know that I start with 25 grams. I can use the density, grams per centimeter cubed, 4.93. 25 divided by my 4.93 will give me my cubic centimeters. What's the volume of, again, in, what am I want it in liters maybe, because they had give it to us in grams per liter. 3.28 grams. And I want to get it into liters. And I have a density of 0.089 grams for every 1 liter. Okay, 92. Okay, where did my thing go? Oh, here it is. All right, so if I have these volumes and I have this density, same old, right? 92. Looking for volume, centimeters cubed, that's our volume. Starting with a mass, 11.3 grams. Use the density, 2.25 grams for every centimeter cubed. All right, volume for bromine, same thing. Put the volume of bromine here. It's grams per cubic centimeter, and then you'll be able to solve for cubic centimeters. All right, 93. Convert the boiling temperature of gold into degrees Fahrenheit and Kelvin. I'm not interested in anybody dealing with Fahrenheit in this class, so we won't worry about that one. But we do want to go from degrees Celsius to Kelvin, and we want to go from Celsius to Kelvin again, and Kelvin to Celsius. Okay, so here's how we know how to do from Kelvin to Celsius. First of all, we have to remember 273.15. That's how many degrees Kelvin there are when we're at 0 Celsius. So that's Kelvin, that's equal to 0 degrees Celsius. All right, 273.15. Now, Celsius and Fahrenheit were glass blowers who could make really good
Thermometers?
yeah, thermometers, that's right. And those thermometers, or those units that Fahrenheit and Celsius used, were again based on chemical changes or physical changes of chemicals that were occurring that they could monitor very accurately, right? But Kelvin was different. Kelvin was not a glass blower, but he was a scientist that looked at a variety of things, one of which was the volume of gases versus their temperatures. So if I were to plot the volume of a gas, at different temperatures, I would see that the volume of the gas followed a linear slope like this. And when they realized that temperature was a measurement of the amount of motion that was in a gas, then they realized that there should be a point where this gas can't stop slowing down. Because if you're still, you're still. That's it. And so because measurement is temperature is a measurement of motion, there is a point at which motion stops, or a theoretical point at which motion stops, and that would be what we would call a zero, an absolute zero, and a point at which no motion can occur, right? And to make a scale that captured that, Kelvin said that's what we'll call our zero. And that happened to be 273.15 lower than the zero of Celsius. Okay? So to go between Celsius and Kelvin, you use this 273.15. If you're at 0 Celsius, you add the 273.15, right? If you're in Kelvin, you subtract the 273.15 to find out what your Celsius is. So with the Celsius here, we just subtract, or we add the 273.15 to get the Kelvin, and same thing with this one. Okay, good.